The key thing to understanding the quotient law is some simple math. What is 2 divided by 2? Or you could write it this way. What's 2 divided by 2 equal to? It's equal to 1. Now, that's not crazy math. If I asked you what 3 divided by 3 was? 1. 5 divided by 5? 1. Okay? Now, the quotient rule is based on that simple fact. Okay? We have powers. We could write this in expanded form. So 2 to the 7, that would be 2 times 2 times 2 times 2 times 2 times 2 times 2. There's 2 to the 7. 2 to the 3 is 2 times 2 times 2. Now, if you use the simple idea that every time you have 2 divided by 2, it's equal to 1, can you see that I could cancel these out and say that's basically 1? And another 2 divided by 2, that's basically 1. And another 2 divided by 2, that's basically 1. And then what are we left with? We're left with 1 times 1 times 1 times 2 times 2 times 2 times 2. If you rewrote this as a power, now how many 2's do you have multiplied together? As a power, though? 2 to the 4, which is, you're right, 16. So the question that you were doing beforehand, and what we're going to try to figure out, is how could I go directly from here to here without having to use the definition every single time? Especially, can you see why in the questions we did before, this one would be terribly annoying to write in expanded form? 2 to the 318. Yeah. Yeah, I guess I could do that as, if you'd like to come for detention, you just have 2 math questions. You have to write in expanded form, that one, and that one. That's your detention. Once you're done writing in expanded form, you can go. Would that not be annoying? Okay. So let's look at the second one. 3 to the 6 in expanded form. Powers mean repeated multiplication. And 3 to the 2. And if you know that 3 divided by 3 is 1, well, this 3 divided by this 3 is 1. And we cancel them out in mathematics because what happens when you times anything by 1?
It's the same.
It stays the same. So you don't need to have it anymore. So that's part of the reason we put a line through it to sort of cancel it out. But what we're really doing is saying that's equal to 1. And so we don't need it anymore. Here's another 3 on the bottom, another 3 on the top. 3 divided by 3, 1. What are we left with? 3 to the 4. Happens to be 81. But the question is, how could we go directly from here to here? So you don't have to show the expanded form. And what that's called is the quotient rule. So when we look at the expanded form, do you notice that, oh, since there were 3 3's on the bottom, it will cancel out with 3 3's on the top? And if they cancel out, how many 3's, or sorry, 2's in this case, how many 2's do you have left? After you cancel out 3 of them, you have 4 left. What's the mathematics that you could use to describe the shortcut from going from here to here? You just have to subtract the exponents. And that is exactly what the quotient law says. Quotient law says when you divide powers with the same base, again, you might want to underline this. This only works if the bases are the same, because they can only cancel out and equal 1 if you have 3 divided by 3. If you have a 3 on the top and a 4 on the bottom, 3 divided by 4 isn't 1. It's not going to help you. So this rule only happens when the bases are the same and you can just subtract the exponents. The nice thing about all of your power laws, if you write it in expanded form, you should be able to figure them out if you forget them. Okay, and I will tell you we're going to learn enough exponent laws that you're going to get them mixed up. So if you ever forget them, you can always figure them out again just by using the definition and rewriting things in expanded form. Okay, simplify if possible using the quotient law. Write your answer as a single power. I'm going to give you a 1-minute head start and come check how you're doing. 4 to the 9 divided by 4 to the 4. If you subtract the exponents, because the bases are the same, you get 4 to the 5. The bases are the same. You could subtract the exponents. You get negative 7 to the 1. Right? Because you're always subtracting the exponents. Now in grade 9, we don't just do it only with numbers, we also do it with algebra. So the bases are the same. The x represents that it could be any number. They could be 5s, they could be 8s, they could be 10s. And if you had the same number on the top and the same number on the bottom, you would just subtract. If you wanted to show your work, you'd say, well, I would just subtract the exponents, leaving me with x squared. The next one is not, you could simplify it with your calculator, but you cannot simplify it with powers because the bases are different. I should have maybe done an example before G, so I'm going to add one in. I'm going to call it f.5. That's halfway between f and G. f.5, if you had 3 to the 7 times 2 to the 4 over 3 to the 4 times 2 to the 1, you could do both of them separately. How many 3's would be left? 3. How many 2's would be left? 3. And you would have to leave your answer like that because those bases are different. When I go to letters, I would do the a's separately. What's a divided by a? Those would just cancel out and be 1. Does that make sense? A divided by a is 1. Just like 5 divided by 5 is 1. 7 divided by 7 is 1. And if a is a variable that represents a number, it's just equal to 1. How many b's are going to be left? Just 1 b left.
Mr. Dreher, I'm confused on this question.
Okay. So when you have more than one power, you simplify the powers with the same bases. So with the 3 to the 7 and 3 to the 4, I can subtract the exponents and get 3 to the 3. With the 2 to the 4 and 2 to the 1, I can subtract the exponents and get 2 to the 3.
And then you add those?
Well, those ones, the bases are different, so at this time there'd be nothing you could do to change it.
3.
Cubed times 2 cubed, you'd have to use your calculator to get an answer for that. To find out that that's 216. So in this one, I did the a's, and since everything canceled out, it's equal to 1. So all my a's are gone. If I wanted to, I could write a 1 out in front. 1 times, and then with the b's, there's 2 b's on top, 1 b on the bottom. After they cancel, you'll get b to the 1. for h, we've got 10 to the 5, and then we've got x to the 10 and x to the 5. These have the same bases, right? So because those have the same bases, I could simplify those by subtracting to be x to the 5. 10 and 5 don't have the same base, but this is dividing. If you wanted to simplify, could you do 10 divided by 5?
Yes.
What's it equal to?
2.
It's equal to 2. Okay. And give you a word.